Hi, my name is Adithya. I'm working as a lead research and development engineer here at Imprintech. Have you wondered how engineers really do material testing? Today, I take you through the fundamentals of the gold standard of mechanical testing or material testing called as tensile testing, or otherwise known as tension test. This has been the conventional way of doing testing for the last 100 years. Tensile testing involves taking a specimen of a certain geometry or a shape, what we call as a test coupon or a dog's bone specimen, and essentially what you're doing is holding it at both the ends and pulling it with certain force, what you see here. So you pull it like this. You're then trying to measure the change in length of the specimen from the initial length L0 to L0 plus delta L as the force on the sample increases. What you essentially get is a fundamental concept in mechanical engineering called as a stress-strain curve. The stress-strain curve has the engineering stress on the y-axis versus the engineering strain on the x-axis. Imagine that you're pulling the specimen this way. The stress on the specimen goes on increasing from 0 here until this point, what you call it as the elastic limit. What essentially does this mean is if the specimen is loaded until this point or below this point, the shape of the specimen returns back to its original shape. Beyond this point is what we call as the yield point, is where permanent deformation on the sample really sets in. So from here onwards, this is called as the plastic region. The stress and the strain really increase beyond this point until you reach the maximum stress that the sample can take, which is called as the ultimate tensile strength. Beyond this ultimate tensile strength, you have a region called as necking. What is essentially that is this area of cross section, that is what you had here, goes on essentially decreasing. So you would have a shape something like this. The area decreases here until it finally breaks at this point. This is then measured, the final break strain is measured at as A. This gives you the final ductility on the material. Although this has been the conventional way of doing mechanical testing, it has certain disadvantages. First, it is destructive. Second, it's quite expensive. Thirdly, it involves many steps in sample preparation. For example, you have to cut it, you have to prepare it in a certain way with a certain length and thickness. Therefore, in the next video, I will bring you through an alternative way of doing mechanical testing using Imprintech's i3D method. Stay tuned for more and looking forward for the next video.